We have arrived to the very last lesson for Chapter 4. It can be Section 7, Absolute Value and Distance. The pacing guide says that this is going to be a 135-minute lesson, so we might drag it out 2 days. Students will use absolute value to find the distance between 2 points on a coordinate plane. Sounds pretty simple. Have you ever visited Washington, D.C.? There are many monuments, memorials, and museums. I've been there. It's a pretty cool place. Lots of history involved there. When touring the city, it might help to make a plan of each location you want to visit and how much time you plan on spending there. You should include in your planning how long it will take to walk or drive from location to location. This means you need to know the distances between these locations. When looking at a map of a city, how can you determine the distance between the Washington Monument and the Lincoln Memorial? These are the things we're going to talk about in this lesson. Our inquiry question asks, how can you use absolute value to find the distance on a coordinate plane? Moving through the slides, and there's 9 slides in this set, so I think we're getting some pretty good details on how to do that. The points are graphed in blank quadrants. Well, let's see here. 2 points are graphed on the coordinate plane. And you can see those 2 points right down here. So since that's where the 2 points are, we can say that both of these points are going to be graphed in the same quadrant. Next, we're going to say, describe a method you could use to find the distance between the 2 points, and what is the distance in units. So we could take and say, well, this one is located at point 1, -2. This one is located at point 3.5, -2. So to find the distance, I could subtract 1 from 3.5, which would give me 2.5 that you can see right here on this line. Pretty easy concept, I think. Now let's take a look at another one. This time we're looking at points that are in different quadrants. We have one located in quadrant 3, one located in quadrant 4. So the points are going to be in these same quadrants. And now we're going to use using only the coordinates. Can you use the same method to find the distance between the 2 points as you did earlier? Well, this time our y coordinates are still going to be the same at -2. But now I've got a -2 for my x here and a 3.5 for my y here. Last time we used subtraction to find the distance. Can we use that still? Technically we can, because 3.5 minus a -2 is going to end up giving me 5.5. And what do you have right there? 5.5. Remember, minusing a negative, that's going to be a positive, but I think we're going to go deeper into explaining that as the lesson goes on. Now we have 2 more points to look at. These 2 points are in the same quadrant, so they're graphed in the same quadrant. They're both in quadrant 4, and they are aligned where they both have the same x value of 3.5. However, the y values are going to be different. Y is -0.2 here and -0.5 here. And if I was to find the difference between those numbers, then I would end up getting a distance of 1.5. Now notice that it was a positive number. Even though my values here were negatives, it's going to be positive because distance is always recorded in a positive, unless you're like going backwards in time and stuff of that nature. So we have a positive distance here. The distance between these numbers is going to be a positive 1.5. And they've given us another one. This time they have a vertical distance between them, but they're landing in different quadrants. One of them's in quadrant 1, one of them's in quadrant 2, so we're going to acknowledge that they're going to be in different quadrants. And then we can say here the x values are the same, your y values are different. So we need to know the distance between these two, and you can count it out as being, well, these are broken down in halves, so that's half, 1, 1.5, 2, 2.5, 3. 3.5, also known as 3.5, which is the distance they gave here. Now there is an algebraic way that you could do this, where you would take and do a -2 minus 1.5, which would give you -3.5 for 3.5, and then you would use the absolute value there to get 3.5, but we haven't really done a whole lot of work with integers yet, so don't stress that one. I do want to point out, though, to you that they have some rules for when they're in the same quadrant versus in a different quadrant. In the same quadrant, if you just took your values here, 2 minus 0.5, you got your 1.5, and that was a pretty simple piece of math to do. But in the one where they were in a different quadrant, went too far, where they were in a different quadrant, doing that math's a little more challenging to subtraction. But what was the absolute value of 1.5? It was 1.5. What's the absolute value of 2? It's 2, and if you add those values together, 1.5 and 2, you're going to get the same answer of 3.5. And that leads us into the last question they have here. Write a rule to find the distance on the coordinate plane where the points are in the same quadrant and when the points are in a different quadrant. So I'm just going to take and show you what they said was their answer for that one. They said when the points are in the same quadrant, I can find the absolute value of the coordinates that do not have the same value and then subtract. However, when the points are in a different quadrant, I can find the absolute value of the coordinates that do have the same value and then add, and that's exactly what I just showed you. You can find the horizontal distance between 2 points in the same y-coordinate with the same y-coordinate on the coordinate plane by using coordinates and absolute value. And we're going to watch this animation to explain how.
When 2 points are in the same quadrant and they have the same y-coordinate value, subtract the absolute values of the x-coordinates to find the distance between the 2 points. The absolute value of each x-coordinate will give the distance from the point to the y-axis. The absolute value of -1 is 1, and the absolute value of -5 is 5. Subtract the absolute values of the x-coordinates to find the distance between the 2 points. 5 minus 1 equals 4. So, the distance between the 2 points is 4 units. When 2 points are in different quadrants, and they have the same y-coordinate value, add the absolute value of the x-coordinates to find the distance between the 2 points. The absolute value of each x-coordinate will give the distance from the point to the y-axis. The absolute value of -4 is 4, and the absolute value of 1 is 1. Add the absolute values of the x-coordinates to find the distance between the 2 points. 4 plus 1 equals 5. So, the distance between the 2 points is 5 units.
Well, that looks pretty simple. The short and skinny of it is, if they're in the same quadrant together, you subtract their absolute values. If they're in the different quadrants, you add their absolute values. And you're going to get the right answer every time unless you make a boo-boo. So let's take a closer look at how to do these. Here they've got 2 points, U and V, and both points are located in the same quadrant. So are we going to add or are we going to subtract? We're going to subtract. If they're both in the same quadrant, we're going to subtract. Next thing we're going to do is we're going to identify their values, their locations, using ordered pairs. So going to my first one, I'm going to run 1/2. I'm going to fly -1 1/2. So 1/2 -1 1/2. That is going to be point U. And we're going to go ahead and capitalize that. And then next, we're going to run 2 and fly -1 1/2. So point 2 -1 1/2 is going to be point V. And we're going to check those answers. That checks well. Now it says since the y coordinates are going to be the same, notice our y coordinates are both a negative 1 and 1/2. Find the absolute value of each x coordinate, and the absolute value of 1/2, this value right here is going to be 1/2. The absolute value of 2, this value right here is going to be 2. So they took and said 2 minus 1/2, which gave them 1 and 1/2 for our final answer. So how far apart are they going to be? They are going to be 1 and 1/2 units apart. It really is going to be that simple. If they're in the same quadrant, you're going to find out which ones or which parts are going to be the same, which the y's were the same, and then you're going to subtract the others. That's all there is to doing it. Now it's going to be your turn. Pause the video, solve this problem, submit your answer. Did you do it? Let's look at some supporting work for me. So I'm going to start off with point G. And point G is located, and don't put equal signs there, I put parentheses here, where you've got 1/3 and negative 2/3. So it's ordered pairs, it could be 1/3, negative 2/3. And then I have point H. Point H's ordered pairs are going to be 1 and negative 2/3. 1 and negative 2/3. The y values are going to be the same, so the difference between the x values, that's going to be how far apart they are. I say difference because they are in the same quadrant. Since they're in the same quadrant, 1 minus 1/3, you could change that to be 3/3 minus 1/3 is equal to 2/3, so they're going to be 2/3 of a unit apart. This is showing your work, people. This is what I must see. If I see anything else, you will of course have done it just for fun. Now we're going to go back to our problem. We're going to type in our answer of being 2/3, accept and check, and we got the right answer. Now we need to take a look at what it would look like if they were going to be in different quadrants. So you can see here E and F are going to be in different quadrants, and what the instructions said was you find the absolute value of each one of these points, and then you would take and subtract them. So we're going to go through the slides and see exactly how they say to do this, nice and slow. To find the horizontal distance between 2 points, consider the scale on each axis. The scale of the axis in this case is 0.25 increments. So you have 0.25, 0.5, 0.75, and 1. And of course these are all negative values. Now we're going to move through the slides to find the distances between the 2 points. First, the coordinates of point E are going to be, we're going to run before we fly, negative 0.75, negative 0.25. So I have negative 0.75 and negative 0.25. I should have a 0 here so I don't want to lose any points. And then for point F, it's going to be positive 0.25, negative 0.25. So we're going to take and have a 0.25 positive and then a negative 0.25. From there, we're going to check that, and those all checked. Move on to the next slide. The next slide says since the y values are the same, they were both 0.25, we're going to find the absolute value of each of the x values. So the absolute value of negative 0.75 is going to be 0.75. The absolute value of 0.25 is still going to be 0.25, and those check. Now all that's left to do is take and add them and say, well, we got to add those, put those values in again, I guess, for it to check. So we're going to retype that and 0.25. And now we're going to say, well, what is it when we add those two numbers together? It's going to be one whole digit. So check, and it checks. Easy math. So the distance between point E and point F are going to be 1. Once again, we added their absolute values of their x's in this case because, their x's in this case because they were in different coordinates or different quadrants. We add every time they're in different quadrants. This looks like a good place for us to stop part 1 of this lesson. When we come back for part 2, I'm going to have you guys solving this problem on your own, so you might want to go ahead and get started on it.